Now we should understand one thing, that when we speak about structural modifications to any planar antenna, the most obvious way of doing so may appear to be cutting slots or adding parasitic patches, whatever. These type of approaches are mostly common. Of course, we will show some modified ways of achieving those later, but let us exploit this popular methodology of modifying any structure. Now, we will begin this structural modification by cutting slots. Or how we can actually cut slots? We can etch out. Etching means removing portion. We can etch out portions of this metallic patch and modify the structure entirely. Let's see. Now, for this demonstration, I will only concentrate upon the patch, not the ground plane. So we need not be bothered about the back side of the substrate. So a front view of this entire structure is sufficient for us. So if we just press the key 5 of our keyboard, the front view will be displayed like this. Okay, the previous view, if you press key 0 once again, you will come back to this previous view like this. This view is known as a perspective view. Perspective view means an angular view, so that you can have an idea about the thickness of the substrate also. You can have an idea about where the back side of the substrate is. But we don't need this here. We are only concerned about the front side of the substrate. So press 5 and get this view. Of course, you can scroll up and scroll down to zoom it accordingly. So let us start working from this view onward. This white portion now is the substrate. This gray portion is the patch, metallic patch, and this is the feed line which you see in front of you. One thing I want to make a point here, that if you want to cut out slots or cut out different shapes from this patch or from any structure, you need to have a very comprehensive idea about the coordinate points, the values of the coordinates at different portions of the structure. What I mean to say, see this graph like pattern which you see here, okay, small squares, imagine them to be a graph paper. Let's say this working plane which is activated here, you can see the cursor, it's basically a graph paper. Now you imagine, now if I just select this feed completely, see the substrate is hidden now, only the metallic patch is being highlighted. See, the metallic patch is shown on top of a graph sheet, something like this. The benefit of doing that is you can actually count the number of squares and guess the coordinates of these points. This is needed. Why? Because if I select any point on this surface, on this patch, suppose this point, we can have a mathematical representation of this point in terms of the coordinates. And what will give us the information of the coordinates? It is basically these small squares which is shown here. So this is the benefit of activating this ground plane. If you deactivate this ground plane, then basically this graph structure will go away. See, I am deactivating this. If you click on this working plane, it's deactivated. This graph like portion is gone. So now it is not that easy to find out the coordinates of each and every points of this structure. Suppose, keeping this view in front of you, if I ask you the coordinate of this point, this junction between the patch and this feed line where I am moving the cursor now, it is impossible for us. Now if I activate this ground plane again, we can actually find out, count the number of squares and actually find out the coordinates. So this is the benefit, and this is absolutely necessary for design, at least in an amateur level. So I will keep this activated, this working plane activated at all times. Now this wire frame is basically, if I click this, see, it will show you the periphery of the structure, the peripheral region of the structure. See, the peripheral region of the structure. So if you are only interested in studying the peripheral mechanisms, in studying the peripheral orientation, whatever, you can very well select this wireframe, which will show the outline of the structure, not the structure itself. But as far as our mechanism, our operation now is concerned, we don't need this. We need the structure completely. So we will deselect it. We will not select it. Okay. Now, while finding the coordinates, we need to know which one is the x-axis, which one is the y-axis, which one is the z-axis. It is shown here. See. Now, if you want to use this portion of the maze, graph maze, and you want to hide this axis, you can very well do that by deselecting this. See, if you deselect this, see, the axis is hidden. But I will suggest you, because we will be working with coordinates completely throughout, let's keep this activated. Next is this bounding box. If I deselect it, see, this bounding box goes away. What does this bounding box tell you? When you simulate the structure, it considers a certain span of the space in and around the antenna. I mean, it does not consider only the antenna, but a certain region of space which is surrounding the antenna. So that is a function of bounding box. If you want to see how much portion of the surrounding is actually considered while simulating the structure, you have to keep this bounding box activated. We need not activate it now, but let's keep it activated because we will be going for the simulation a bit later. So we are keeping on activating it. Okay. The other options are there. The other options we will just check out as and when the time needs. So different viewing mechanisms also are shown here. If you activate this span as mentioned, you can actually move the structure up and down and left and right. That means either along the vertical axis, which is the y-axis here, or along the horizontal axis, which is the x-axis here. If you zoom it, then you can actually zoom the structure. Okay. Rotate. Now let me show this first. Rotate in plane. Rotate in plane, if you activate it, then you won't be able to see the other side of the substrate. Suppose this is showing you the front side of the substrate. If you rotate in plane, you can rotate it. I mean, you can't view the other side. See, always the front side is visible. Okay, always the front side is visible. So if you want to do that, you can always keep this rotate in plane option highlighted. But if you want to select or if you want to see the other side of the substrate, you have to activate this 3D rotate option. Okay, see, activate the rotate mode. Okay, if you rotate, if you select this, then you can actually see the other side of the substrate also. Okay, so this is the difference between, this is the cross section. This is the difference between the two types of rotation operation. Okay. So I will again press 5 so that this front surface is visible to us. And we will start off with the modifications. Now, like I mentioned, that we will cut slots at the beginning. Okay. So I hope all of you remember what was the Boolean addition operation. The Boolean addition operation is basically combining, joining two different structural components. Generally, those two structural components are of the same nature. Either both are metals or both are dielectrics, like this. Very rarely, we actually join a dielectric with a metal, or more generally, we join two different materials. Very rarely we do that because that will not have a profound effect on the simulation results. So like the last session, what we did there was we joined the patch with the feed line. So we removed this junction over here and they blended into a single metallic structure. Today, While cutting slot, I mentioned the term etching out. Etching out means removing portion. So we will do the exact opposite operation as a boolean, I mean in terms of the boolean. Last time we did the boolean addition operation. This time we will go for the boolean subtraction operation. So they are completely opposite, but this boolean subtraction operation is a bit different than the boolean addition operation also. There is a very finite point of difference, which also I will explain. So let us cut out the first slot. Now, as far as the design which we prepared, the patch had the dimension of 30 cross 30. So we fixed the coordinate center, the origin at the center of the structure. So the X range was from minus 15 to plus 15. I can show you the range also. We can click this history list. This was the patch. Double click on the patch. See, the patch dimensions are visible to us. X range is minus 15 to 15. Y range is also minus 15 to 15 because we designed the square patch 30 cross 30. So this way we used to define the dimensions. And Z range is 1.6 to 1.602 because it rested on top of the substrate. The substrate has a thickness of 1.6 and the thickness of the metal is 0.002. So the Z max was 1.602. Till this much we did. So from this information, what is the coordinate for this point? See, according to the basic concept of coordinate geometry, this lies in the second quadrant. This point lies in the second quadrant. In the second quadrant, X is negative, Y is positive. So this point will be minus 15, 15. I hope all of you have understood. This point, now this point, this corner lies in the first quadrant. In the first quadrant, all are positive. Both X as well as Y dimension are positive. So the coordinates of this point will be 15, 15. This is the third quadrant. This corner point is in the third quadrant. In the third quadrant, X is negative, Y is also negative. So the coordinate for this point will be minus 15, minus 15. Now this point lies in the fourth quadrant. In the fourth quadrant, X is positive, Y is negative. So the coordinate for this point will be 15, minus 15. So as of now, we just need to refer these 4 points coordinates only. Coordinates of these 4 points only. So 15, 15, minus 15, 15, minus 15, minus 15, and 15, minus 15. These we will note down somewhere. Now suppose I want to cut out a rectangular patch from this portion. From this top portion, like this, I want to cut out a rectangular patch. Okay, I hope you can follow how I am indicating. Okay. So it is very certain that this patch which we will be cutting out will have a smaller dimension than this entire patch. That means it will not stretch from minus 15 to 15. It will have a lesser stretch. It will not have a stretch in the y direction from minus 15 to 15. For that also it will have a lesser span. Okay, so keeping in mind this, let us define the first slot that we wish to cut. So for doing that, first we need to select this modeling tab once again. Then a new option I will show you today. It is the extrude option. See, this was a brick option which I discussed while designing this structure. Brick, this sphere, this cone, this torus, cylinder, etc. Now just below brick, you have this particular icon. Okay. If you place the cursor here, it will show you extrude face. Extrusion. What does extrusion mean? Extrusion literally means removal. So extrusion means you are basically removing a face, removing portion of a face from some portion, from some patch. Okay. So if we want to cut out a slot, this is the option which we have to select. Okay. See, left click on this and press the escape button of your keyboard. This dialog box will come which shows extrude profile. Okay. Extrude profile means now you need to define the slot which you want to cut out. You are not actually cutting it out. You are defining the structure which you want to cut out. So let us give the name slot 1. Slot 1. The next tab is orientation. Orientation means you have to indicate that direction which is perpendicular to the slot which you are cutting. Now imagine, come back to the structure here. The slot which we are cutting is from the patch itself. So it will have dimensional properties, dimensional qualities of the patch itself. Now imagine, try to visualize. This is the X direction along the horizontal on your screen. This is the Y direction on your screen, vertical direction. What is the Z direction? The Z direction is actually either coming towards you from the screen or going inward into the screen. So if I ask you now, which direction is actually perpendicular to the patch? It is the Z direction, perpendicular to the plane of the patch. Now since we are cutting out the slot from the patch itself, the perpendicular direction of the patch and perpendicular direction of the slot will be the same. So if we want to select that particular direction which is perpendicular to the slot, it will be the Z direction only. Z is selected here. In case something else is selected, we need to select the Z only. Okay. So Z will be selected here. Next is Z min. Now we are cutting out the slot from the patch only. So the Z min for the patch and the Z min for the slot, they will be the same, because we are cutting out from the same structure. So what was Z min for the patch? It was 1.6. So we will put 1.6 here. Now there is a difference here in the coming step. While designing the patch, we defined Z max, which we put to be 1.602. Here we are not having any Z max. Instead we are having this height. Height means height of the material or thickness of the material which we are cutting out. What are we cutting out? We are cutting out metal only. So the metal has a fixed thickness of 0.002. So in height, we need to define that. So in height, we will write 0.002. No need to do anything with this twist and taper because they are used for generating curved sections. We are not doing that now. Now, see here, points are given, X, Y is there. That means, see, if you cut out a slot like this, a rectangular slot like this, that rectangular slot will also have 4 points, 4 terminal points, 4 corner points. You need to define those corner points under this table, under this points. Okay, that's what we will do now. Now, as I already mentioned, that this slot basically will have a smaller span as compared to the entire patch. So they will not stretch from -15 to 15 in the X or in the Y direction. They will have a smaller range. Let's see how it is done. Now let us select that we will cut out the slot from here, for example, say. Now see, this is 15. So let us take half the distance. So 7.5. So this point is say -7.5 somewhere here. So what will be the exact mirror image point here? Plus 7.5. Because they are exact mirror images of each other. This section and this section, they are exact mirror images of each other. So the first point, the X coordinate, I will put -7.5. Press tab. Now see, we are cutting out the slot from here only. So the upper limit, that means the Y max for the patch, will match with the Y coordinate of the slot. So we are cutting out from here. So this point will have the same y max point, that is plus 15. So we will put plus 15 here. I hope you have understood why we have put plus 15. Enter. Now see, this point is actually shown to you, this point. Now we will take the point here. So for this point, the y coordinate will remain same because we are at the same vertical level. So y coordinate will be 15 only, but x coordinate now it comes to the this side. So this will be positive 7.5. So 7.5 tab 15. Enter. See, it is shown here. I hope you can see the demarcations. Next is we will come down like this. We will come down like this. Okay. So if you are coming down, see the same horizontal level is maintained. So x remains 7.5. So x remains 7.5. Put tab. Now y is not 15. Y has come down a bit. The point here has a y coordinate value which is less than 15 because we are coming down. Let us take 10. Enter. Now we will select this point, the point here on the left side. So for the point on the left side, again see the same vertical level we are having. So y will remain 10, but now we are coming to the left hand side. So x will become negative. So we will have minus 7.5 tab 10. Okay. Now we won't do anything because for defining this rectangular slot, we needed 4 coordinates. We have defined the 4 coordinates. Now this component we won't change because from the beginning only, if you remember, we did not change the component. Component was component 1 only. Now this material indicates which material you are cutting. Now you people think we are cutting from the metal only. From the patch only we are cutting. So what is the material that we are cutting? Metal. PEC only. So material will be PEC only. So we will not change anything. If mistakenly you select something else, the materials which are already defined, if you select something else, then the extrude option will not work. Fine. So this is the final thing. Before you confirm it, just preview the structure. See, if you place preview, this wireframe is appearing, which shows that this is the slot which you intend to design. So it matches our expectation. So we put OK. Now observe one very careful thing. While we were defining the slot, first point we defined is this one. Next point we defined is this one. Third point was not this one. Instead, it was this one. So we have to follow a particular sense of rotation, either clockwise or anti-clockwise. We can't mix and match. So if you select this first, this second, this has to be third, this has to be fourth. Not the other way. First, second, then you can't come this to be the third. Now similarly, if you start from here, you can consider this to be second. In that case, this will be third and this will be fourth. So we have to follow a particular sense of rotation. Okay. That is one thing which we should observe. Second thing is that, see, we have defined the slot which we intend to cut out, but still now it is not cut out. It is there in the structure only, it is there. It is defined. I mean, with this boundary, it is defined that this you intend to cut out. Because of this only I mentioned this word intend to. Okay. So for cutting out, we have to use the Boolean subtraction operation now. Where will you find it? See, under the modeling tab only, see this Boolean option is there, but it is hidden now. You can't access it. Okay, you can't access it. For accessing and performing this operation, here there is a difference with the Boolean addition operation. Now I hope you will remember that when we use the Boolean addition operation, that means we were adding the patch with the pig. We double clicked on the patch first. The patch got highlighted. We activated Boolean addition, then we double clicked on feed, pressed enter, then these two shapes were fused together, combined together. The same thing would have been obtained if we double clicked on the feed first and then the patch. That means in Boolean addition operation, the order in which you are adding, whether feed to the patch or patch to the feed, that is not important. In either case, you will get the same result. This is same as mathematical addition. Whether you add 3 to 6 or 6 to 3, you are bound to get 9 only in the answer. Same thing is happening here. But in case of subtraction, it is not like that. Mathematically, if you subtract 3 from 6, you will get 3 only. But if you subtract 6 from 3, you will get negative 3. Now in mathematics, getting a negative difference is allowed. You can actually get it. But in Boolean, in design, in this Boolean subtraction operation, a negative difference is not allowed. You will get an error. So we need to select from which we will subtract which. That means generally we have to decide, we have to judge on which is the larger structure from which we are subtracting, and also which is the smaller structure which we are actually subtracting. That is very essential here. Okay. So as far as this in front of us, this structure in front of us, which is the larger one? The patch only, where I am moving my cursor now. And the smaller structure is this slot which we have defined. So what we will do, we will double click on this patch. See, when we double click on this patch gets selected including the slot. The slot is not shown now. And at the same time you observe this Boolean is now activated. We can actually access this Boolean. So what we will do, now we will not select this Boolean because by the default operation is Boolean addition only. If you select this Boolean, automatically the addition operation will get selected. You can select the same Boolean addition from the drop down also, but by default it is add. Now we will subtract. So after double clicking on the larger structure, here it is the patch. When the patch gets highlighted, you select this subtract. See, this tab comes. Now you have to double click on which you want to subtract. What we have defined to be the slot 1. Now there are two options of doing that. Either you have to visualize where the slot was. Suppose the slot was here. Okay, we know that the slot was here only. We can double click on this. See, the slot gets highlighted. And we can press enter so that the slot gets cut out. But in many systems, this additional option is not there. I mean, if you select this slot, I mean, if you double click on the top edge of the patch where the slot was actually there, the slot won't get highlighted. Or if you make any mistake, suppose instead of double clicking on this slot, you are double clicking actually here, which is a bit less, I mean, a bit lower than the actual slot, then this slot won't get highlighted. So in that case, what we will do? In that case, let's select this component once again. In that case, what we will do? We will double click on this patch, like what we did. Boolean gets activated, drop down, subtract. Instead of double clicking here, we will select this slot from the navigation tree. Can you see the slot 1 in the navigation tree here? Now, if you select this slot, see, the same thing happens. Okay. Now, if you press enter on your keyboard, see what happens. The slot has been cut out. And you don't get any existence of the slot here. Slot has been vanished because the slot is being cut out of the main structure. So the mention of the slot is no longer there. Okay. So this is the way, basic way in which we cut out a slot from a patch.